Hello, everyone. Whoop, hopefully these transition. Okay, just a quick update for those who don't know what IceCube is. It's a cubic kilometer of ice that has been instrumented with over 5,000 optical modules. So basically, we sit at the South Pole and have done this at the polar ice cap, which is mostly due to the material. Basically, building a similar experiment a mine, etc., would be prohibitively expensive, but nature has given us some some help here. The detector is large in the physical volume, so as it says, those sort of scales of energy of neutrino type, saying that certain neutrinos interact, for example, in the Earth's crust or outside the detector, and then their products can be seen in the detector. So as they travel through the detector. Besides sort of neutrino astrophysics, which is our main driver, we also have a number of other science drivers across particle physics, fundamental symmetries, beyond the standard model physics, but also earth sciences. So mostly in the sense of it's very particle physics heavy, but there's also sort of secondary science goals that we have that go much broader than this. So quickly, just how it works. So we have something called a shrink-off light, which is just a sonic boom, but with light. So you typically see this in nuclear reactors. And what basically happens is instead of charged particle travels through the medium at faster than the speed of light in that medium, and gives off some light as it loses energy. So in IceCube, this means, for example, a muon neutrino can interact with the detector, and then the resulting muon from that interaction travels through the ice and gives off light or emits light, and we detect that light. So from a 30,000-foot view, we're sort of classical particle physics computing, ingeniously parallel, as Frank likes to say. We have these time periods of interest, which we call events. The number of channels varies by event, and ideally we would like to compute on a per event basis. Basically, the smallest unit of compute for us is the event. We have several caveats here. We have no direct network link to the experiment, so we're really dependent upon when it comes to data transfer from the experiment. At least we're really dependent upon what NSF provides to us. We have those extreme conditions of -40°C. We require specialized hardware, so we have this jump from CPU to GPU back to CPU. We have a lot of in-house developed software and specialized software because of this. And we have this sort of massive science reach that is very different from some other experiments in terms of energy. That makes it really difficult for us to do some sort of predictive scheduling. So how we compensated for this is sort of we have this heterogeneous global resource pool similar to all the other experiments that are going to talk here today. But what is different is we don't have a lot of dedicated resources. We mostly operate on shared mechanistic resources. That means OSG and EGI are sort of our biggest contributors in terms of resources, but then also we have folks that have their local cluster that are not hooked up to OSG or EGI. Again, one of the big things is that we use GPUs for our simulation, and that is our sort of one of the biggest hurdles for us. We do a lot of different physics simulations. We don't just run GANT or all day long. We do have these non-standard packages like Corsica. And then we have this large science reach, which means that, as you can see in the bottom plot, about 10% of our workloads have a very large memory requirements, and that gives us sort of adds to the overall need. And then we keep evolving, as this is an emerging field, especially in multi-messenger astrophysics. It's only really been a thing since 2017. We have this sort of very evolving mission that we have to accommodate. So just sort of an additional note on our grid infrastructure. We have this sort of pledging infrastructure that we started in 2016. So it's over 5 years ago now that basically we have folks from across the world pledging resources. The issue is tying this all together. And of course, we can't hosted CEs. We're sort of a twinkle in Brian's eye at that point. And we've had issues with our workflow management system that was trying to basically replicate Condor in some ways to scale beyond, to scale to the scale we needed. So we built our own based on Condor. So we basically have Condor in terms of a sort of a private grid, then on top, then we have Condor running inside Condor and on the OSG and EGI. So today we have sort of a mishmash of authentication. So this seems somewhat, I would call it traditional AI. You have sort of a local identity that you carry around everywhere, and then that you carry around internally for our resources. So this is all LDAP backed, where you have sort of this IceCube data center that provides data warehousing, cluster, some interactive compute, and some ancillary services such as email, document services, the business side of things. And we basically have, and it's a password-based access for the most part. So you have users, using passwords or a key pair to get to the data, and then do all their work locally. That is kind of falling in. And the issue really comes down to that most of our compute resources are external. That means users would currently have to use X509 to shuffle their data around from the compute source and back. And that's a very big hurdle for folks. We do have some, other methods like stash cache where it's run over CVMFS, and we have no auth on that. But then we also have an HTTP access for those folks that only want to pull data. The issue is still getting the data back from the external compute resource, and there, X519 is really currently the only path. On the Condor side, we are basically spraying the world with all pool passwords. So if you want to contribute, you can contribute, but ultimately this is not necessarily the best in terms of cybersecurity. So as I said, you have these collaboration pool passwords and collaboration shared passwords. So some folks don't need necessarily, they just want to access data. So we have a group password, but you're scattering this around several thousand nodes every day. So from any cybersecurity researcher will tell you that is crazy. And we've had instances where folks are using key pairs, but also password-based authentication is just prone at this point to attacks. And it has given us a headache more than once. Also, as I mentioned, the X509, the grid certificates have been the biggest roadblock for researchers. Initially we still had OSG issuing certificates, which made some things easier, but now with OSG no longer issuing certificates and everything going through CI logon, we're having this mishmash of certificates, especially because in some countries, getting a certificate can be difficult if you're not from the large experiments. It literally takes, going to an office and handing over your ID for them to issue your certificate that lasts for a year. And you can imagine a grad student that's on an experiment for, a finite amount of years, having to go somewhere else to get a good certificate, a digital piece of paper is a major hurdle. Similarly, the sort of understanding of why it's needed and how to transfer all these various files is simply too much hassle for a lot of grad students. But the biggest issue, though, is really returning the data from the job. So, you can do a wget to get the data, but then, you have some output, and that output is necessarily, can be a few hundred megabytes. And now, you can't just do a wget put to put it back into the file system, but rather you have to use X509, and then everybody starts scratching their head. So our plan is basically to replace most things with tokens. So we're currently in the middle of doing many changes on the AAI side. The biggest one is that we're moving away from sort of having everything LDAP back and moving everything into Keycloak. as our identity store. That means it provides us with an OAuth2 and token generation, that OAuth2 features and token authentication scheme that we can then use for our data transfer, but also for offloading services. So we're in the middle currently. Once Keycloak is all set up in production, we'll offload more and more of our sort of quote unquote business services. That means email, documents, calendaring, etc., to Google, and people will use OAuth2 authentication to get to that. Then we're working on an HTTP and an events-based transfer of data, and we want to use Sci tokens and JWT-based tokens for that. Similarly, we have just recently switched to an HD Condor issue token for our flocking from our local UW-based or UW-Madison-based cluster to CHC, and then of course OSG. But with our PyGlidin, we want to also move to token-based authentication, and we're in the middle of revamping our PyGlidin software to do exactly that. We'll still have the CBMFS or stashed cache over CBMFS with no authentication, but that has only been used by some people by a handful of people for their work. So this is only certain applications that really can use the power of the caching for their data. So as I said, there is this massive change for us to an OAuth2 based authentication of web services. So for example, the to come is that we want to have federated identities that people can log in with their, for example, University in Europe ID into our web services, and then get issued a token because of this federated identity. We also want this sort of more granular access control that has been a big issue for us with X509, getting users to having that, users can only write to this directory with their username and things like that. With X509 has always been sort of an issue, have mapping grid identities to usernames. And then some people have gotten, then we have group accounts, production accounts that are very different, that, their authentication is also being sprayed across the grid. And that's a big issue for us. But then with the granular access control, we hope we can reduce that risk. And we want to ultimately reduce our password-based authentication. I mean, OAuth2 will still be, there will still be a password involved, but there's a much stricter sort of security frame around that. And of course, then we can also bring in federated identities, as I mentioned, as sort of an easier path for the user. And similarly, as Brian said earlier today, OAuth2 over SSH is really something that we're looking at as sort of a path forward without sort of bringing users to making it easier for users to be safe, but then also having only one identity that they need to sort of deal with. So that's it from my side. Please let me know if you have any questions.
Thank you, Benedikt. Reminder, the Google Docs is there for each section. So if you have some extensive conversation with Benedikt and other members, please put them there. Any questions for Benedikt right now before we move to the next talk? I don't see.
This is, oh, sorry, Pascal.
Oh, go ahead. Yeah, I didn't see any hand raised, but go ahead.
Yeah, I'm cheating because I can. Yeah. I had to look away a few times during your talk, Benedikt, but just what would you say your sort of overall timelines for making these changes are? And do you feel like things are on track or ahead of schedule, behind schedule?
Things are on track. I mean, we will hopefully have Keycloak online by end of this month, middle of next month, and then we'll slowly start tokenizing everything. I mean, we hope that, I mean, if you guys turn this off, it will be accelerated. I mean, it will be moved up on the list, but you know, we are aware that we'll hopefully by end of this year, beginning of next year, we'll have moved most services to tokens.
Okay, that sounds great. Thank you.
Okay. Any other questions for Benedikt?